Relations and functions. A relation is a pairing of elements of one set of elements of a second set. Typically this is written as a set of ordered pairs. The domain and the range. Usually domain is the x values, and range is typically the y values. So note, the domain is defined as the set. So anytime you write what the domain is, you have to make a set. And a set in set notation means that you start out with a brace, you list your elements separated by commas, and you end with a brace. Same thing with the range. It's a set. Domain is a set of all the first values in the ordered pairs. Range is a set of the second values. And once again, typically the first value is an x value and the second is a y. A function is a relation in which each element of the domain is paired with exactly one element of the range. An element is anything. An element can be a number, can be a letter, can be a person. It's just a thing. Typically, when I try to explain what a function is, perhaps I don't do it the greatest because people often get confused about it. Basically, for a function to be a function, from relation to be a function, if you put a number into the relation, you should only get one answer out. No matter how many times you put that one number in, you should get the same number out every time. If you do that, it's a function. If you can get more than one answer out, then it's not a function. Example A, state the domain and range of each relation. Note, since it says to state the domain and range, your answer has to be a set. If it's not a set, it's not correct. Then state whether the relation is a function. Circle yes or no. Important to note, if an element is repeated, you only have to write it once. So looking at number 1, what's the domain? Well, the domain is the set of all x values. Our x values are -1, 3, and 6. In a set, the order in which you write your elements does not matter. I typically write them in ascending order from smallest to greatest, but it doesn't make a difference. You can put them in any random order that you want. The range is the set of all y values. We have a 4, a -5, and a 2. Once again, the order does not matter. Is this a function? Well, let's see. If I put in a -1, you put in x values, you get y values. What comes out? A 4 comes out. If I put in a 3, I only have one choice. A -5 comes out. If I put in a 6, out comes a 2. This is a function. Let's look at number 2 here. State the domain. Domain is the set of x values. We have a 0, a 5, a -3, and a 0. This is where this note comes in. The 0 is repeated. So when you write the domain, you don't write 0 twice. Each element should only be named once. So we got a 0, 5, and -3. Notice I wrote those in random order. The range. I have a 5, a 7, a -6, and a 0. Has to be written as a set. Is this a function? It's not. Here's the reason. If I put a 0 in, I can put it in here or here. I have two choices for what's going to come out of this. A 5 can come out, other times a 0 can come out. Since I can get two different responses from the same input, it is not a function. Example B. Given that x is an integer, let's examine what the word integer means. An integer is a whole number, positive or negative, and it also includes 0. So example, -3, -2, -1, 0, 1, 2, 3. Those are integers. No decimals, no fractions, no imaginary numbers. So given that x is an integer, state the relation representing each of the following by listing a set of ordered pairs. The answer has to be a set, and inside the set you have to have ordered pairs. An ordered pair is parentheses with an x value, comma, followed by a y value. That's an ordered pair. Once you've done that, state whether the relation is a function by circling yes or no. So, number 1, we have y equals 2x minus 2, and we're told that x is bigger than 0 but less than 5. Since x is an integer, that means that the domain for this problem, if it's bigger than 0 and it's an integer, it could be 1, 2, 3, or 4. It's less than 5, so it doesn't include 5. So we're going to take each of those elements, 1, 2, 3, and 4, and one at a time put them into the x value into this equation. So, for example, take y equals 2 times 1 minus 2, replacing the x with a 1. It's going to give us y equals 2 minus 2, which is going to give us y equals 0. So an ordered pair that we get from this, we put a 1 in and we get a 0 out. You do have to show every step of these problems. Cannot skip steps. Now let's put a 2 in. Y equals 2, substitute a 2 in for the x. Note also, when you substitute a number in for a variable, you are to put it in parentheses. Sometimes it will affect your answer, sometimes it won't. But if you always put it in, if you always put the parentheses in, then you'll never have a problem. 2 times 2 is 4. 4 minus 2 is 2. So the ordered pair, we put a 2 in, we got a 2 out. Notice putting boxes around my separate work. The reason is I don't want this work to flow into this work. It's a good habit. Most people, the math problems that they have, there's a lot of most there, is they don't organize their work. If you don't organize your work, then you're going to have problems. So now I'm going to put the element 3 in for x. 2 times 3 is 6. 6 minus 2 is 4. So I put a 3 in and I got a 4 out. So I have an ordered pair 3, 4. Finally, I'm going to put 4 in. And I simplify it. I get the ordered pair 4, 6. So my relation, I'm going to move this stuff up a little bit, it's in my way. State the relation as a set of ordered pairs. So let's do that. So a set, and then I have the ordered pairs 1, 0, 2, 2, 3, 4, and 4, 6. And your set. Is this a function? It is, because if I put a 1 in, I only get one response. That's a 0. If I put a 2 in, I only get one response. I put a 3 in, I only have one choice. I put a 4 in, I only get one choice. Yes, this is a function. Number 2. Once again, we were supposed to state the relation listing a set of ordered pairs. So for this problem, my domain is going to be 5, 6, and 7. You don't, when you do your work for this, you do not have to show this step. You can if you want, but you don't have to. So here my domain is 5, 6, and 7. So I'm going to take my function, y equals 1.5x, replace the x with a 5. 1.5 times 5 is 7.5. So my ordered pair is 5, 7.5. My next integer is 6. So we got y equals 1.5 times 6. Six times 1.5 is 9. Make that look a little more legible. So that ordered pair is 6, 9. Last one is 7. Put a 7 in. That's going to give me 10.5. So I have the ordered pair 7, 10.5. Second part of the directions, actually I guess the first part of the directions, state the relation as a set of ordered pairs. I have the set, and then I list my ordered pairs. If you don't write this answer as a set, it's wrong, because the direction said write it as a set. And my set, is this a function? Yes. If I put a 5 in, I only get one choice out. I put a 6 in, I only get one choice out. I put a 7 in, I only get one choice out. Is it a function? Sure is. Next we have function notation. A function is commonly denoted by f. It doesn't have to be f. Could be any letter. Well, I shouldn't say any. I don't think I've ever seen it written as an x or a y. Typically any letter other than x or y. In function notation, the symbol f of x is read, coincidentally, f of x. F of x is the same thing as y. That's really important. F of x simply means y. Nothing more, nothing less. Therefore, the ordered pairs of a function are in the form xy or x f of x. And that's because, once again, y means the same thing as f of x. It's simply a different way to write it. What's nice about function notation is when you finish a problem, you know exactly what you put in for x. If you look back to these examples that we did here, I don't know if you noticed, but I hesitated every time I got to the point where I wanted to write an ordered pair. Because I knew my y value was 7.5, then I had to look what was my x value, and I looked what was in the parentheses. If you use function notation, it's obvious what you put in for x because you're writing it right beside the x. Example C. Given that f of x equals the absolute value of x squared minus 11, find each value. Let's read this note first. You must simplify inside the absolute value before getting rid of the absolute value symbols. Some people make the mistake and they think absolute value means make everything plus. Well, it's not true. You don't make this a plus sign. You simplify everything inside the absolute value. Once everything is simplified, then the final result is a positive. So number 1, f of 0 means I'm going to take my function and replace all the x's with 0. Notice you use parentheses when you make a substitution. You do one step at a time. Math is based upon the principle of doing one thing at a time. So what is 0 squared? That means 0 times 0. That, of course, is 0. 0 minus 11 is negative 11. The absolute value of negative 11 is positive 11. So there we go. F of 0 is 11. Put 0 in, we got 11 out. That's why I like function notation. F of negative 4. Substitute the negative 4 in for x. One step at a time. Negative 4 squared means negative 4 times negative 4. That's positive 16. Negative times a negative is a positive. This 11 is 5. So it's the absolute value of 5. So f of negative 4 is 5. I wanted to make a note here. This started out as f of 0, and then I have a blank spot. If you ever leave a blank spot on an entire side of an equation, it is assumed that that's the same thing that was above it. This was also blank. You're allowed to leave that blank if you want. But in your final step, I would very much like you to write the left side of the equation and the right side. Number 13, f of the negative square root of 13. Or number 3, f of the negative square root of 13. So I am going to take and replace the x with negative square root of 13. Do it in parentheses. Seems intimidating, but it's not. We have a negative squared, which is going to be a positive. Negative times a negative is a positive. Also, the square root of 13 squared. Squared and square root are inverse operations. They cancel each other out. Therefore, this is going to be a positive 13 minus 11. Once again, a negative times a negative, because you're squaring it, gives you a positive. Square root and a squared, they're opposites. They cancel, so you're left with 13. 13 minus 11, we get square root of 2, which gives us f of negative square root of 13 equals positive 2. Next, we have vertical line test. If every vertical line drawn on the graph of a relation passes through no more than one point on the graph, then the relation is a function. I'll explain that more when we get to this problem down here. Example D, use a graphing calculator to determine whether each equation is a function. If you use a graphing calculator for this, you're going to find that you have a y-intercept here at 0, 1. This graph is real tall and skinny. It's going to look something like this. So, the directions, graph it, and then determine if it's a function using the vertical line test. It doesn't say using the vertical line test, but anytime you have a graph, and you're supposed to determine if it's a function, that's really what they're asking you to do. So here's my vertical line. If I take this vertical line and I move it over top of this graph, at any point is the red vertical line hitting the blue curve in more than one spot. If it does hit it in more than one spot, then it's not a function. If it only hits it in one spot at any given time, then it is a function. So this passes the vertical line test. So this is a function. Number 2, we got y equals the square root of the difference of x and 3. If you put this in your calculator, you're going to find that it has an x-intercept at 3, and it's similar to this parabola that we drew over here for number 1, but instead of curving to the right and up or to the left and up, it curves real fast to the right as it goes up. This is the same kind of curve as this, but it's only half of it. So does this pass the vertical line test? Yes. At no point does it hit the graph in more than one location. So yes, this is a function. This is not how this problem was, but let's just say for argument's sake that this problem had more of the curve that went down like this. This is not a function, because you can see with this vertical line, I'm hitting this here and here at the same time, so it's not a function. But once again, that doesn't happen for this, so yes, that's a function. Example D, use a graphing calculator to determine whether each equation is a function. You can't put this into your calculator in its current form. And that's because y is not by itself. To get y by itself, you're going to need to subtract x squared from both sides of the equation. To get y by itself, then, you square root both sides. When you square root, when you do any kind of even root to both sides of an equation, the answer is going to be plus or minus. There's a positive version and a negative version of the answer. So y equals plus or minus the square root of 49 minus x squared. Now if you try to find the plus or minus button on your calculator, I'm pretty sure it doesn't exist. It could. I've never seen it. So when you put this into your calculator, you're going to have to put into y1, the positive version of this, and then into y2, the negative version of this. Those two things together will give you your complete graph. And here's what it's going to look like. It's going to be a circle. It's going to be a circle that crosses the x-axis at 7 and negative 7. It's going to cross the y-axis at 7 and negative 7. C for center. Does this pass the vertical line test? No, it does not. If I take this vertical line and run it over this graph, you can see there's lots of times, nearly every time really, that it's hitting the graph in two locations at the same time. So, not a function. Hopefully you remember from Algebra 2 and Geometry and Algebra 1, this here is the standard equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center and r is the radius. That's how I was able to graph this. 49 is r squared, therefore r is plus or minus 7. Well, radius is always positive. So I know the radius was 7. If you notice, there's no parentheses here, like it does have over here. Therefore, when it says x squared, it's really saying x minus 0 quantity squared and y minus 0 quantity squared. So the center is 0, 0. That's how I was able to graph that. Hopefully you remember that from Algebra 1, Geometry, and Algebra 2. I know it was taught to you. Example E. The symbol bracket x means the greatest integer not greater than x. So it's the greatest integer, that's a whole number, positive or negative, including 0, that's not greater than the number that you're given. What that basically means, I have this in this note over here, it means to round down to the nearest integer. If you're given an integer, you don't round it at all, because the greatest integer that's not greater than that is itself. If you're given a decimal, you need to round it down to the closest integer. Let's look at example number 1. F of -4 equals, substitute in for the x, the -4. To get rid of these brackets, this bracket is an operation, just like plus, subtract, just like absolute value, squared, that's an operation. You can't get rid of the bracket until you do the operation. It's a grouping symbol, which means you have to do it first as well. You cannot add 6 and -4 together, because this -4 is not a -4. It's the greatest integer not greater than -4. So what does this round down to? Rounds down to -4. If you have an integer inside this symbol, then the answer is just that integer. That's real simple. -4 plus 6 is 2. If you're a little confused, that's fine. When you see a couple more examples, hopefully you won't be. Number 2, f of 2.5. Perhaps I'm contradicting myself a little bit here. I want to make an explanation. Notice I didn't put the substitution here in parentheses. You can. I said always do it. So I guess I should do it. The reason I didn't do it is because this is already a grouping symbol. There's nothing else inside of it, so it's kind of redundant. But if you want to be safe, always put in parentheses whatever you're substituting. So I'm going to make sure that I try to do that so I can be consistent. So this means the greatest integer not greater than 2.5. Is 2.5 an integer? No, it's not. So you're supposed to round that down to the closest integer. That rounds down to 2. So just to make sure that's clear, and I'm not trying to insult you, but this is going to come into play here. May seem silly, but sometimes taking an extra 2 seconds solves a lot of problems. I'm going to put 2.5 on a number line. Put the closest integers to the left and to the right of that 2.5. I got 2 on the left and I got 3 on the right. Round down means you're going to the left. So it rounds down to a 2. 2 plus 6 is 8. I'm sure that you were screaming because that was so obvious. Let's look at this next one. It's not as obvious. If you don't believe me, pause this video, do number 3, and then when you're finished, unpause it and watch what happened. It's likely that you made a mistake, because most people do. So, substituting, we get the greatest integer not greater than -6.3 plus 6. Keep in mind, I don't know if I made it clear, I'm getting the equation from up here. It's the equation I'm supposed to use for each of these. What's the greatest integer not greater than -6.3? Most people would say, well, it's easy, it's -6. It's not. But on the number line, this becomes very clear. So we got -6.3 on a number line. What's to the left of that? is negative 7. What's to the right of that is negative 6. Negative 6 is bigger than negative 6.3. Or at least I should say, bigger is a relative word, I guess. Negative 6 is to the right of negative 6.3 on a number line. Negative 7 is to the left. So if I'm going to round down, this is negative 7 plus 6, which is negative 1. Next we have excluded values. Definition. Real numbers, when substituted in for x, will give you an imaginary number for y, or be undefined. 2 times in this class we're going to find excluded values. One time is if it makes your denominator equal 0, because if your denominator equals 0, that means it's undefined. And then another time, this is almost true what I wrote here. Values that make the radicand negative. That's not entirely true. It's values that make an evened root radicand. Values that make an evened root radicand negative, because in that case it's going to be imaginary. Even root means square root, fourth root, sixth root, an even number. An odd root would be like a cubed root, a fifth root, a seventh root. So how do you find excluded values? Simple. Set your denominator equal to 0 and solve it. If you have an evened root radical, and it's an even radical, take what's inside it and set it so that it's less than 0. Let's look at some examples here. Example F. Name all values of x that are not in the domain. It comes in 2 varieties. One variety is if you have a radical, which we do in this problem, and it's an even root radical. This is an even root because this says square root. It means there's actually a little 2 here. It's an even root. So to find excluded, excluded means what we cannot use, because if we did use it, we'd get an imaginary, or we would get an undefined answer. Take your radicand, radicand is what's inside the radical. This is an x plus 8. That's what the radicand is. And we say, if that's less than 0, we're going to get an imaginary answer. So we take x plus 8, say it's less than 0. We solve this by subtracting 8 from both sides. And our excluded values is anything less than negative 8. If you put any number in for any number in for x that's less than negative 8, you're going to get an imaginary answer. If you put a negative 9 in, negative 9 plus 8 is negative 1. Square root of negative 1 is imaginary. Number 2, supposed to find values of x that are not in the domain. That means excluded values. If you have a fraction, which we do here, to find the excluded values, take your domain, set it equal to 0. Our domain, that's the bottom of the fraction, is 32 minus x squared. If I add x squared to both sides, square root both sides, when you take an even root, it's plus or minus. I'm going to have plus or minus the square root of 32 equals x. This radical can be simplified. You do not have to show the work for how to simplify it, but you do have to do it. So I'm going to show it here just in case you've forgotten. This is one method. This is not the method on how to simplify radicals. It's one method. 32 breaks down to 2 times 16. 16 breaks down to 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. For each pair of the same number, since it's a square root, that's why I said pair, for each pair you put one number on the outside. Anything uncircled stays on the inside. Therefore, the excluded values are plus or minus 4 square roots of 2. 2 times 2 is 4. You can always check this to see if you simplified your radical right. Take the number on the outside, do the opposite of the square root. So 4 squared is 16. Multiply it by the 2 on the inside, you get 32. Same thing as I started with. So excluded values for this is plus or minus 4 square roots of 2. Note, ladies and gentlemen, the reason that I wrote excluded, I think it's important. Sometimes we get in such a rush when we're doing math that we forget what we're doing. This direction says name values that are not in the domain. You're going to find other problems that say state what the domain is. So this is what's not in the domain. Other times, what is in the domain, if you write excluded here, you know when you're finished it's what's not in it. Number 3, we got to do a lot of work here because we have a fraction with a variable on the bottom. We also have an even root radical. So we're going to have to do the work that we did for 1 and 2 all together here. So excluded values. Going to take my radicand, set it less than 0. My radicand is what's inside the radical, x squared minus 9 less than 0. I'm going to say some weird things here. To my knowledge, there's no direct way to take a polynomial such as this x squared minus 9 and solve it when you have an inequality symbol. Weird things happen. So you're going to hear me say something that's not mathematical. I don't know what the best process is for mathematicians across the world, but this is what I do. I pretend for a moment that this is an equal sign, and I solve it. Solving this, I'm going to get x squared is 9, and I'm going to get x is plus or minus 3. When you square root both sides, you get two answers, a plus and a minus. This is not the answer, though, because this is supposed to be a less than symbol. If you left it as a less than symbol this whole way down, you would end up with x is less than plus or minus 3. That doesn't make any sense to me. X is less than 3, and it's less than negative 3. It sounds like it's saying the answer is just things that are less than negative 3, which we'll find is not the answer. So I'll come back to that in a moment. Now let's finish that. Let me explain how to finish this part, because we still have the denominator part to do. On a number line, take your solutions. We have a negative 3 and a 3. There's all different kinds of numbers on this number line. We're just noting these two numbers. Break the number line into different parts separated by these solutions. So I got this, and I got this. I got to the left of negative 3, I got to the right of 3, and I have between negative 3 and 3. Then pick a test point, any number that you want, in each of these intervals. I'm going to pick negative 4, 0, and 4. Take your inequality with zeros by itself, which is right here. Mentally, or physically, plug in these test points. If I put a negative 4 in for x, a negative 4 squared is 16, 16 minus 9. Is the answer positive or is it negative? That's all we care about. It's positive. If I put 0 in, 0 squared minus 9, it's going to be a negative. If I put 4 in, 4 squared minus 9 is going to be a positive. The reason we only care about positive and negative is because if you look at this inequality, x squared minus 9 is less than 0. Less than 0 is negative. So from this, we get our answer is between negative 3 and 3. And I want to go back a second, something I wish I had done here. These vertical segments that I have here, I want to use dash segments, not solid. Here's the reason. A dash segment means that it doesn't include that number. This says less than. It doesn't say equal to. It just says less than. Since it doesn't include that number, I'm going to use a dash segment. So when I look at this answer, I get from this that x can't be, it's excluded value, so x can't be between negative 3 and 3. All this goes together. So this is part of my answer down here at the bottom. The other part, I'm supposed to take the denominator, the denom, set it equal to 0. My denominator is the square root of the difference of x squared and 9. If I square both sides, that's the opposite of squaring. I'm going to get x squared minus 9 is 0. Therefore, x squared is 3. Therefore, x is plus or minus 3. So from this part of the answer, I get that x also can't be 3 or negative 3. If I put those two together, these two answers, this is saying x can't be between negative 3 and 3. This says x also can't be 3 or negative 3. If I put those together, then I'm saying that x can't be between or including a negative 3 and 3. That's my final answer for that problem. And the reason I had to do both denominator and radicand for that, because there's a radical on the bottom of the fraction. Number 4, f of x equals 7 divided by the difference of the absolute value of 3x and 5. When solving an absolute value problem, you need to get the absolute value by itself. That's important. Refresh your memory on how to do absolute value. First of all, we're trying to find excluded values. Notice the beautiful penmanship. Take my denominator, set it equal to 0. My denominator is the absolute value of 3x minus 5. To get the absolute value by itself, which is what it's telling you up here in this note, get the absolute value by itself, I'm going to add 5 to both sides. Once it's by itself, this separates into two separate problems. Separated by or, because the answer is this or this. On one of these, I just simply remove the absolute value bars. So 3x equals 5. Or the other one, I take off the absolute value bars, and then the side that did not have absolute value, I make the sign negative. So it could be 3x equals 5, or it could be 3x equals negative 5. If I solve each of these, I get 5/3, or I get negative 5/3. So what is the excluded values here? negative 5/3 and positive 5/3, which you can write both of them, or you can just write plus or minus 5/3.